Welcome to the Troxel Podcast. I'm Evan Troxel. This is the podcast where I have conversations with guests from the architectural community and beyond to talk about the coevolution of architecture and technology. A little bit of housekeeping before I introduce my guest for this episode. Would you like to receive my Troxel AEC Tech newsletter that I send out on a weekly-ish basis? In it, I link to and comment on the quickly evolving tech and AEC landscape. Each edition has a curated short list of things that I think are worth paying attention to so we can all be aware of how tech and AEC are evolving. I won't spam you ever, so if you'd like to get my free newsletter, head over to trxl.co and click on one of the subscribe buttons. Okay. In this episode, I welcome Daniel Inocente. Daniel is an architect, space architect, adjunct professor of architecture at Arizona State University, and co-founder of Atom. He has experience working for architecture and engineering firms and government, including SOM, Gehry Partners, HKS, and NASA. Daniel's expertise spans various sectors, including commercial, transportation, aviation, government, culture, science, education, and residential. He also has worked in the aerospace industry, leading partnerships with government and commercial partners. He integrates interdisciplinary and diverse ideas, leveraging his combined knowledge of architecture, technology, and space architecture. In this episode, we discuss the field of space architecture, which involves designing infrastructure and habitats for space exploration and colonization. We talk about design challenges, including optimizing volume, co-locating spaces and functions, and developing sustainable communities. We also chat about the design process that involves working with experts in material science, engineering, propulsion, and radiation, who and what is currently inspiring Daniel, and more. So without further ado, I bring you my conversation with Daniel Inocente. Daniel, welcome to the podcast. Thanks for joining me today.
Thank you for inviting me and for having me here.
All right. Well, I would love it if I know a little bit about your backstory and it's fascinating. So I would love it if you would tell the story of your trajectory in your architectural career.
Yeah, with pleasure. So I studied architecture. I was born and raised in Los Angeles. I was surrounded by a lot of very interesting activities happening in architecture, especially with, the West Coast architects, Frank Gehry, Tom Main, looking at progressive movements. My interest in architecture began when I was in high school. I really wanted to dive into a field that was both creative, but also technical and allowed me to bring conceptual ideas into the world, in concrete terms. And so architecture really inspired me to think about that. And I read a lot about the work that Frank Lloyd Wright was doing, Le Corbusier, Gropius, just all the modernists, and even going back through time, looking at historical works. And so for me, that was always inspiring. The challenge of how do you take an idea about settlement, about building, about construction, architecture, and then bring that into the world through different lenses. And so technology has a huge role to play in that. And I've also been fascinated by technology, thinking about digital technologies and how we can start to use technology to help design better buildings, better cities, and visions for the future. So that's a little bit about my background. And then eventually, I finished school. I got to work with Frank Gehry, Gehry Partners. Got to work on some pretty exciting projects there. Very artistic, hands-on, building models, designing, sketching, using 3D modeling software. I even got to work on his personal house at some point, a new house that he was building. And so I was on site with the contractor, with the builders, 3D modeling, producing drawings, helping them build his house. And then I also got to work overseas when I was there. So I got to work on projects in the UK, Battersea development, and that was really exciting. His design aesthetic was really out there, pushes the envelope in terms of creativity. But to get to that creativity, you have to go through a lot of technical hurdles. And it's not just about, construction, but also how do you communicate that idea with a contractor, with a manufacturer, with a builder, and digital modeling had a lot of importance in that.
Yeah.
And then eventually I got to work for NASA for a year. And so that kind of rekindled an interest of mine that I've had since childhood in space, and like about that later on.
Okay.
Then I moved to the East Coast. I worked for HTS in Washington, D.C. for a couple of years, and eventually ended up in Manhattan working for SLM for 5+ years. And while I was there, I got to work on mixed use developments, high rise, airports, museums, cities, like, large scale urban planning, just a wide range of projects really around the world. And at the same time, I was leading research efforts in space and kind of like reigniting this interest that I had of mine from when I was a kid, and thinking about space and how we can, as architects and designers and urban planners and engineers, bring ideas from the terrestrial world into the space sector, kind of leading up to where I am now.
Yeah.
Now I work as a space architect.
Great. And you're teaching as well. And so you're kind of bridging the gap between academia and practice. And I mean, that's a little bit unique because there's many people teaching who are not also practicing. They might have a similar experience as you, working in medium and large offices, and that has led them to teaching in design studios. But continuing to practice, a lot of people have kind of pick a place to land, and they pick academia if they're a tenured professor. It takes up all their time, I'm sure. And so you're still kind of bridging between two worlds of academics or I should say academia and practice, right? And as a space architect, it's still, well, you tell me, conceptual? Is it still very conceptual work, or is it actually going through the process of building? Because you talked about this, the importance to you of synthesizing ideas into reality. And it seems to me like the time frame for space architecture is, you tell me how long it is, but it's still out there. Like it hasn't hit yet, and we're not building in space yet. And so I would love to hear kind of your take on all of that, because of your passion for both of those things, academia and space architecture at this point.
Yeah, I think that touches on the importance of research. Before, I think for every architect out there, or any significant work, or you get that big commission, you have to have some thinking behind it. There has to be some research behind it. And that's what we actively do, as thinkers, designers, architects. We're constantly looking for ways to solve problems.
Right.
And so that precedes the problem itself before you actually have the opportunity to solve that. And for me, academia is very important. Always wanted to teach. I had the opportunity to start teaching at Arizona State University. It's a very different environment, an amazing campus, very interdisciplinary. They have a lot of different departments, faculty, experts in different fields. And I love talking to them, especially with the architecture department. They're very creative and looking. And so they gave me the opportunity to teach studios there around design, master studios. And so these are students who are just finishing up their masters and going out into the world. And they're interested in thinking about architecture through the lens of space architecture, through thinking about digital design, other ways of, improving built environment.
Mm-hmm.
And so what I try to teach there is, I try to teach a little bit of interest in technologies that are outside the domain of building environment, like the AEC industry.
Yeah.
And then help them think through ways of, how can I take some of those ideas or technologies and bring them into the terrestrial world? And so one studio I had was, I introduced students to thinking about space habitation, and then understanding what are the different kind of components and technologies that go into space habitation, challenges. And then immediately after that, I said, okay, so now how do we design a facility where you can develop those key technologies, basically like a space research center? And those space research center become, just like an ecosystem of development, where you can start to produce new materials, start to test new materials, do things like 3D printing, do some material science. So there's a lot of different programmatic components that come into this. But I believe that if we're going to talk about space, going to space and making it sustainable, we need to have places where we can develop this technology, develop these systems. Most of the time, this is happening, in the domain of like government agencies where they do testing,
right,
but also in large aerospace companies where they have facilities. A handful of aerospace companies can do that. But if you can give that capability to students and to young entrepreneurs, I think you can accelerate a lot of the thinking that is pushing us to go, into space and think about permanent space habitation and settlement, other things. But yeah, I would say for bridging the gap between research, academics, and practical applications of space architecture, it's definitely not easy, because when you're working with an environment as hostile as outer space or on different planetary bodies, there's so many factors that go into it, not to mention the cost associated with developing these key technologies or capabilities. There is a lot of, I would say, support for that, not just here in the US through NASA, but also abroad at different space agencies. And I've had the opportunity to work with different space agencies in Europe and other universities around the world. And so this is a global, thing that people are pursuing, and it's being tackled from different vantage points. There's also competition, but that's good. That's healthy. Healthy competition is always good. And there's definitely a lot of progress happening now. If you keep up with the news and aerospace developments, you'll see that there's a lot of interest in going back to space, to the moon, to Mars, and making those technologies possible. But I always love teaching, so I'm going to continue to teach, and I will try to challenge students in different ways. Well, next semester, I'm actually teaching something very different. It's high-rise studio, so thinking about high-density urban development in Manhattan. And I have a site for the students, and I have some ideas about what it means to develop high density in a time where housing is very important, in a time where sustainability is very important, and where we're kind of rethinking the way that we work and live. And so that's, I think, also another important topic. Maybe not, I would say, not completely connected to space architecture, but that's where I come from.
Yeah.
I worked in two different worlds, and I'm still fascinated by the two worlds. And every once in a while, I find ways to break up. It's not always clear. And people ask, well, how do you do these two different things? It's not clear to me either all the time.
Yeah.
You just have to connect the dots whenever they become visible.
Yeah. Yeah. I think, you said rethinking the way we work and live. And that to me is something that happens all the time in academia. There's a constant kind of questioning of why do we do it the way that we do it? And at the same time, we are still teaching students today the same way that we've been teaching students for decades upon decades, for a profession that is slow to change, right? It's slow to adopt new business models. It's slow to adopt new technologies in much of it, not everywhere, right? There are obviously, the bell curve is real in architecture too. There's the early adopters, there's the late adopters, there's the whole gamut. And so I think you're probably more on the earlier adopter side for sure, right? At the innovator side. And, but you can't, my question, I guess, is, or maybe I'll provoke you and just say, like, how do you square up with the academic system as is when it is really designed to pump out graduates into the existing situation that so many of them will find themselves in, which is of the past, right? Like, it is very much built on the practice of old, not the practice of new. You have, I think, found a different path, and you can even communicate that to students, and you can show them that they don't have to fit into the quote unquote, project manager role or the designer role in a traditional firm, because there are additional avenues out there. But I feel like you're against the grain in a system that's not changing very quickly either. In addition to professional practice, neither of them are changing very quickly. You're on the bleeding edge, but how do you kind of square that, and how do you approach that when you're talking to students?
Yeah, and one thing is for sure, you're never going to have a smooth ride when you're trying to do things like this. Like, you're always going to find friction, and so it's good, actually. Resistance is good, because what I've discovered is, for every individual, there's always like something that is innate to you, whatever interests you, like, if there's a saying that we're all unique. I think we're all genetically unique. There's something unique to you, unique to me, unique to every individual. And if you can tap into what makes you different, really fascinated by it, and you just like master that, it becomes easy for you to do that. You work hard at what things that are easy for you. And if you can do that in architecture, you might find a niche where it's like, I'm interested in, architecture through the lens of software, or I'm interested in architecture through the lens of economy or philosophy or sociology, whatever. And then you tap into that potential and you start to, craft a different mindset. It makes you different. It sets you apart. It becomes your power, and that's, I think, one thing I try to tell students is, don't try to repeat what others are doing. Definitely don't, I'll share my journey with you, but don't repeat my journey. Everybody has a journey to take and you have to discover that. But always question, if I'm doing something, am I enjoying it? And if after a certain period of time, you're not enjoying it, you have to find a way to shift gears. Mm-hmm. You have to find something that you're really, truly enjoying, because the only way you could get good at something is through a lot of hard work, repetition, and sometimes that comes forward. And then you want to shift over to something else. And you have to really dive deeper into something that's interesting, and you can push the boundary in that way, but it has to come towards you.
Yeah. Yeah. The whole idea of space architecture is really interesting because there is so much being learned about how to build in other places, right? And so you talk about kind of the extreme or really harsh conditions as far as, humanity would be concerned in other locations that are on different planets, right? It could be on the moon, could be on Mars, as a couple of, examples that are probably, readily, and we can see that happening. And so when it comes to, like you talked about specific kind of facilities, ecosystems for developing ideas for habitation of other places like that. And there's so much being learned so quickly. How are you sharing that with students so they're not always starting from scratch when it comes to designing or pursuing ideas for habitation on other planets? Is there a compilation of knowledge that's being collected and made available to students in that regard, beyond the government agencies who tend to keep all of that stuff secret, I would assume? I mean, maybe I'm wrong, but it seems like architecture has always kind of suffered from this, where it's everybody has to go it alone. All the students are prepared through school to approach each project from a blank page, which is in one way, it's very good, right? It's fresh thinking. On another way, it's you are reinventing the wheel in many cases, right? And so how do we get beyond that? And how do we share? You're a bridge between space architect and student, so you could share it personally. Is it happening at a scale larger than that so that we don't suffer the same consequences we have here, which is everybody has to pay their dues. Everybody has to climb the same ladder. You have to suffer the same way that I did through the process of becoming an architect. And so I'm just interested if that's changing at all when it comes to space architecture, or is it more of the same?
Yeah, I guess in academics, so far I've experienced a lot of free flowing information. Mm-hmm. People are willing to share, willing to help, willing to connect you with resources that you need. And then, of course, when you get into commercial world, it's always a competition. Certain companies, firms have a secret sauce, whatever that is. Sure. And they don't want to share that with anybody because they're all competing for different clients, especially in the AEC industry. And I've experienced, a combination of that, and not just in the aerospace world, but also in the building world. And so I sometimes see it as not necessary. I think the more we share, the faster we can move. Mm-hmm. Protecting ideas, protecting IP sometimes can get in the way of progress. But it is also a good metric for innovation, capturing new ideas, technologies, patenting, and then documenting that, and just making sure that we're together collectively creating new ways of solving the problems as a society. But I do say that there is a lot of great resources for students. Once you get to a certain level, once you get to let's just say the hardware level, or even the technical level in the building design, you're going to come across a threshold where you can't access that information unless you're on the inside. But there is enough information out there, especially with the internet now. You can learn how to do great engineering, learning a lot of things about design and the building industry, aerospace. NASA, our government agency, they publish a lot of work. If you go to their NASA Tech work, they have a roadmap, really well documented roadmap. All the different discrete technologies and capabilities are needed to sustain humans in space on the moon and Mars. And these are all areas where we can actually go and say, I have an idea for this technology. Maybe I can come up with a company to develop this technology. And so if you're inspired to do that, go and check out, the roadmap there. But then there's also publications. If you go, NASA has really great website for publications. And these are a lot of them are government funded. They're in partnership with universities. The AIAA is also a really good resource for this, publications. And there's also great conferences. So one thing I tell students is go to conferences, go to networking events, go meet other people, connect. And you'll find that that's one of the best ways to, just to accelerate your career. Face-to-face interaction with other experts and professionals, because anybody who's successful will not deny you, some help.
I say the same thing. I feel like conferences are so important for exactly that. The best part of a conference is not the classes. It's not the keynotes. It's not the expo hall. It's the person-to-person interaction that you can have, and making real-world connections. Definitely, it goes above and beyond online connections. And I don't exactly know why, because I can connect with anybody anywhere in the world. I mean, this podcast is an example of me doing exactly that every single week, talking to people all around the world, but it doesn't compare to meeting in person, right? So there's just something different about it. And you really do have to take those literal steps to get out there and do that, and pay for a ticket to those conferences, even if it, figure out a way to get to those conferences. I know a lot of people who will they will not attend a conference, but they will go to the place where the conference is happening, because the great conversations happen outside of conference hours many times. And they'll just meet up with people for dinner, for coffee, for whatever, because they know that they're going to be in a certain place at a certain time. And it's a great time to connect with people. So I totally agree with you. I think that is one of the best ways to get out there and gain the knowledge that only people, I should just say that people are more willing to share that in person over a very low key conversation, a very real conversation, than they are going to be pushing that stuff over email or whatever, for whatever reason. But it's just, that is actually how it works.
Yeah, absolutely. Everybody wants to connect.
Yeah.
And so if you can find a good motivator to connect, find something that you love doing, and then go to those conferences and learn from other people.
Yeah. You strike me as the kind of person who's been really motivated to get out there and experience things and connect with people. And that seems to be the trajectory that you've lived in your career. I love how you follow your passion. Like you said, you also tell the same thing to your students. If you're getting bored with something, often that's a sign that you're not growing, right? And so you do need to find the next thing that you are interested in to drive the growth, and that will lead to new opportunities. It'll lead to new connections and all of those things. What are you interested in now? What are you nerding out about right now that just gets you so excited about where the industry is headed, where you're headed, things like that?
I will say one thing though. It's like, okay, it's not just getting bored and then shifting, but having the ability to be bored, but still want to do it. Like, okay, you know that something is going to take a long time to do, but you know that the end product is way more rewarding. And so you see it there. But I encourage the students always, like, see your project through, and like, even if you don't like the idea now, like, the vision. So just keep iterating, keep designing, and eventually you'll get to a solution that you feel works what you initially thought you were going to get to. I'm very much interested in the problem of building and building with technology, building smart. I think information technology has a huge role to play in the future. Obviously, it's changing the way that we design, it's changing the way we create. If you look at, machine learning and AI, these are tools that are transforming different markets and sectors. But I think it has a huge role, and this is nothing new. I'm not saying this something novel, but it's been for decades. But I think it has a role to play in the way that we communicate with and optimize our built environment. And so I think, like the idea of ubiquitous computing, ubiquitous technology and sensing devices and information will change the urban world, will change our houses, change our transportation systems. And it's already doing that. I just got a Tesla and I just love how easy it is to use. Information that's communicating with me, how it slows down. Auto driving is such an incredible feature. But it's communicating with you. It's actually connecting with you as a human and augmenting your ability, making your life better. And so I feel like housing could do that. And so I started to venture into prefab and smart homes. And so me and a partner of mine who used to work with me at SLM, we started a company called Atom, and we're building our first smart home here in New York. And it's a really cool process because we're using manufacturing in shop, we're using digital modeling, we're using computational design, we're looking at materials, sustainable materials, passive house certified products, and then we're also producing a platform to help manage and communicate with the user in terms of like resources, energy, water, all of the resources that we need to sustain a house. And so that's been an interest of mine. And it's also, I think if you think of design, design, when you start to look at it through the lens of systems, like systems of systems, and this is also speaking to the engineering I do, is systems of systems thinking helps you really create products and solutions that anticipate the future. It's like life cycle. If you design a building now, how is it going to be used? How are the occupants going to be able to adapt it? What is the way of tracking, the different metrics, how people are using it? And then what is the end life product? Can you design something for recyclability or repurposing, future optimization?
So many times an architect's job on the project is over when the plans are submitted to a contractor. And, there might be some construction administration, maybe not. Depends on what the client hired the architect for. And then it's like on to the next project. And the next project is, starting at the beginning and going to that point again, and then doing that rinse and repeat. It seems to me like the things that you were just talking about give an architect agency to keep the relationship very much alive beyond that turning over of the keys. I hate to call it post-occupancy. It's actually just occupancy, right? It's not, so many architects will do a post-occupancy survey, and it's like, how good is that? That marks a point in time, and it's not after occupancy. It's like the whole idea of calling it that just seems wrong to me. You can't call it post-occupancy, but it's occupancy, right? And it's living with it now. And it's actually seeing if the hypothesis of the design is actually performing, is actually providing the things that you were set out to do in the very beginning. And so I think sensors, the tech that you're talking about, gives us it opens the door to continue those conversations, to continually improve the built environment beyond handing over the keys, because we're so risk avoidant, right? We're like, okay, I hope they like it. I hope they don't sue me. I'm working on the next project. And we tend to step away from that responsibility or that possibility, that opportunity to continue to, from an architectural lens, learn from and make adjustments that will continue to make that building perform in ways that really serve its occupants. What do you think about that? Is that one reason why you're excited about this kind of technology, or are you thinking about it from other viewpoints?
Yeah, definitely. So like part of it is design and part of it is, working with a contractor and manufacturer. And then part of it is developing a technology, which, most likely be under a different entity, but that technology could plug into the house, and then the house could be the heart, the backbone, the chassis or the hardware that supports that. So, but it has to be equipped with all those sensing mechanisms, devices, and then you have to be able to update them and replace them. As we know, computer technology is transforming really fast. It's processor or sensor today, next year is going to be much better, much faster. But then having knowledge of that, like just understanding how to design around smart systems, that's just like another layer that you can work. Like architects, we work with different dimensions. And so like there's the experiential dimension, there's economic dimension, constructability dimension, all these different dimensions. And we're just adding another one. So like, I think that's how I see architecture often is, we think in terms of dimension, and then whatever dimension you as an individual designer particularly interested in seems to like come out the most, and you can see that in different works, different signature architects, whether it's like aesthetics or expressing structure or material, all these different ideas. But for me, that's interesting. How do you collapse all these dimensions and then make it for a living environment?
Yeah. Yeah. I mean, and you've worked in offices that kind of have those different ethoses, right? Like SOM is one of their, I think, design criteria. One of their values is expressing structure through the aesthetics of the design, right? Like they don't want to hide the structure. They want to express the structure. They want to show you what makes this building stand up. And I always found that to be a really interesting value that they seem to make available in every building that I've experienced that they've done. And, Gehry's got Gehry's version of that, and the different places that you've worked have their different version, or what that list is with the highest priority for them is pretty apparent in that. So when you're working on projects, give me an idea of what the priority is for you when you're designing.
So looking back at some of the large projects I worked on, I've always started with, so first, of course, structure comes into play, but, there's always like this domain, which is geometry, especially in large buildings. And geometry is kind of the basis for how you start to break up a building system, because that geometry plugs into all the different variables. And you start to export things like, like areas where you put the transportation system, like cores, structural, the envelope. And then you start to build on that. What is your enclosure system? But for me, it's like a combination of looking at geometry. There always has to be an idea behind that geometry. It can't just be geometry for the sake of geometry. And then there has to be an expression, and that expression then it transforms, it shifts based on the structural idea. And so there's this kind of like emergent quality where you're working with an engineer, and then they give you some feedback on what the structure could be, and then the spans of the structure, and then you start to fine tune the overall form. And then that's somewhat, like dictated by the areas and the mix program. And then you start looking at things, environment qualities like daylighting and, heat gain. And there's all these different layers. And so for me, that's why digital technology, computational design has been so important, because it's a tool that I've learned to master. And then I can plug in all these different variables. I can take weather data, I can take, like FVA analysis software, take CFD software, I can plug it into my workflow, and then it starts to inform how I think and design. And it's important to like also have a team with certain expertise to help you, to guide you through that process, whether it's like internal planning, the layouts, or whether it's thinking about, how do you integrate building integrated photovoltaics, or if you're working with like an enclosure system that has metal cladding or terracotta, stone, whatever. And then you start to like bring those elements into your design. And yeah, sometimes I think we can be a little bit forceful because we have an idea and we're like, this is exactly how it's going to look. And then you introduce a material that doesn't want to work with that, but you're like, we got to make it work somehow. Yeah. It's going to be complex, but we'll make it work. So you have to learn how to be flexible. And of course, that's something that we're all constantly learning. It's like, how do you collaborate and how do you connect with people and give people agents and authorship over your ideas.
Design is such a series of trade-offs, right? It's there's like that idea, the golden thing that you don't want any occlusions to happen in, and then there's the realities of money and physical constraints and what the materials can actually do and how they perform and what the environment needs, and so you're constantly trying to balance and juggle and make the right decisions about trade-offs that will serve the end result in the best way. And I think that's what's so interesting about the challenge of architecture and the problems that we're willing to take on to try to solve. And to me, that's just like one of the most incredible things about architecture is just the never-ending challenges with all of those different pieces that are kind of influencing the recipe that ultimately gets baked into the final building.
Yeah. And I guess the best thing you can have in a project is an amazing site, an amazing client, all these amazing like collaborators.
Ideal
where
perfection.
Everything works.
Yeah.
Everything works together well. And then sometimes you're solving issues that are undetermined. I've worked on master plan projects where we're thinking about future generations.
Yeah.
For like 10, 20 million people.
Oh, wow.
And like, how do you expand the city in a certain area? And then what kind of infrastructure do they need? And what kind of building typologies? And how do you design around that? And so that's maybe like a little bit more forward looking, but you need to throw those ideas out there. You can work stakeholder constituents to help get that work done.
Right. Yeah.
It's not
communication. The main job of an architect is communication as well as all of those other things, right? It's an underrated skill, but it's also something that can be developed as a true skill to actually orchestrate all of that to turn into reality at some point.
Yeah, absolutely.
So you talked earlier about mastering digital technology. I would love it if you would just kind of go through the tool stack that you have mastered and just talk about that, because I think there's a lot of questions out there. What tools should I be using? And I hate to say the answer is all of them, right? But you use the right tool for the job. And you talked about CFD and FEA analysis and all these different things. And so maybe you can just kind of run through the different things that you're using on projects, not just so that we can name drop what all the tools are, but just to give people an idea of what's going out there in the tool set of a space architect.
Yeah, it's just like first, it's like a pencil. Like what size lead are you using or whatever? Yeah. Are you using a pencil or a brush or a pen? The tool changes the way that you design and the way that you think often, and so it's important to keep that in mind. A certain tool is good for one thing, not necessarily good for another thing. And I've always tried to stay on top of software tools. I just know that they enable designers to think through the problems. And yeah, definitely, like, another thing I should say is the idea of mastery. It's not something you just like, let's say you get good at using a tool. It doesn't stick with you. You have to practice it all the time. Otherwise you stop using a tool for 6 months or a few months, and then something new came on, a new feature, the new technique, and you're just like trying to stay up to date with these things. You can never stay up to date with.
Yeah. But
it's fun to try, it's fun to try to stay up to date with the latest and greatest. I've used Rhino a lot since I was in school. I used Rhinoceros. It's a really incredible tool because it can be used for any industry, all scales, from jewelry to cars to airplanes to buildings, right? Like, this is an incredible tool. You can work in different units. You can do analysis. You can do visualization. You can work with plugins, a lot of different plugins for Rhinoceros, whether it's environment. I would say it's one of the most powerful tools you can use as a designer. And I've also used Grasshopper. I mean, I've gotten really good at Grasshopper, spent way too much time behind Grasshopper. And it's just one of those tools where it becomes like an environment of its own. At some point, you get so good at it that you don't even have to look at the 3D modeling environment. You can just look at the graph, and you know what you're doing. Like, as long as you don't get any like red boxes,
It's interesting to think of Rhino just as a Grasshopper viewer, right?
Yeah.
But it is sometimes.
Yeah. And the greatest challenge with Grasshopper is like data sets. Like, how do you structure data? the trees, and then how do you move that data from one step to the next? Because if you do it incorrectly, your computer will crash or you just won't get the output you're asking for.
Mm-hmm.
So it's up to you
a
to
lot
know
of problem solving and troubleshooting in there.
Yeah, like how to graph or like distribute the data sets, break it. And then I've also really enjoyed working in industrial design software like CATIA, SolidWorks. These are tools that really help you get into like the detail, the nuts and bolts of idea that you have. At some point, I remember I was because I used to use Digital Project when I was at Gehry's office. And then I got really interested in using the latest version of CATIA, which was the cloud-based CATIA, the 3D experience. And so I started using that early on. I was one of the first users. I was part of this like tribe group with a bunch of experts around the world. And we were invited to conferences in Europe and to basically talk and using their tools. And we were helping inform the development of the cloud. And that was really, I have friends who still work at that company. And then at the same time, they started developing a platform, which is similar to Graph. Basically, it's like a Graph, like friendly user interface for being able to produce move data sets between different platforms. But I think tools like that, cloud-based tools, parametric computational tools, that can absorb a bunch of information very quickly, that can take you from something conceptual, basic geometry, to something that can communicate a fabrication model. Like we talk a lot about in the industry, fabrication ready models. That's important because when you're designing, and if you can take the design from concept all the way through a fabrication model, you're kind of recreating what's going to be built in the real world. And so you're solving all those problems. And the 3D environment helps you learn very how things work, tolerances, connection, material. And that's always been an interest of mine. So I learned how to use, Digital Project early on in my career. I used 3D Experience, and then I got into SolidWorks, and I still use Rhino and Grasshopper today. One thing that I haven't been able to crack is documentation. We always have to deliver data documents.
Yeah.
And so like Revit is still the tool of choice. There's no other tool out there that can produce graphics, quality of graphics that Revit can. Annotations and dimension. But Revit is not a great, I'm going to say design tool in terms of like big ideas, but it is a good design tool for solving, assemblies and technical detail. Things come together.
Right.
Yeah. But there's also a disconnect there because nobody will tell you this, but when you have a Revit model, like very small portion of it is 3D. The majority of it is like a bunch of 2D line work, and it's all disconnected. And then you have like this Frankenstein where you have a design model, Rhino, and then you have your Revit model that's trying to like imitate the design model. And then you have a bunch of drawings that are not connected to the 3D environment.
So the coordination gets lost there, right? Because the connection is broken. Yeah.
And then that makes it even harder to change a design, because if you go back to your original design and you update that, then you have it,
now you're back to AutoCAD, right? Where you have to manually check every drawing that is referenced from every other drawing. Every BIM manager who's listening to this podcast right now is just pulling their hair out hearing this, right? Because you never use filled regions. You never use, you never use model lines. You never use drafting lines. It's like you draw it right. And it is so hard for people because they don't have the deep knowledge of the application to be able to pull that off. Or maybe they don't have the time to invest to figure out how to do that in the quote unquote right way, because the timelines vary very quickly. And then we end up taking these shortcuts, and then because we didn't do it right now, we have to redo it later. And so we've spent even more time because we don't look at the whole timeline of how much time it actually takes to do it and apply the right thinking to that. So we're perfectly happy spending the time redoing the work later because we didn't do it right the first time, but that doesn't make any sense either. So I just wanted to kind of include the people who were pulling their hair out into this conversation to say, like, it's true. It happened. What you said happens all the time. And yet it's almost impossible to fix it because not everybody can get to that level in every piece of software. It's a true problem of our industry.
Yeah. And I would say it's not like we need to develop fabrication drawings, don't always get that scope.
Yeah.
Or need to do that level of detail, especially in the beginning.
Mm-hmm.
It's nice to have a way to take information, interoperability from one platform to another, and then have it all somehow connected.
Yeah.
And everybody talks about like, oh yeah, I developed this process and it like seamlessly connected me from year to year. I've been in long enough in this field where I know that's not true. I know that there's a lot of like workaround, customization, and what works for one project wouldn't work for a project.
It's the Wild West. Yeah, it absolutely is. Talk about the kinds of projects that you've worked on. I mean, you don't have to go all the way back, but just in the last few years, what are the kinds of things that you're doing with these tools to give people an idea of like what a quote unquote space architect does?
Well, maybe I go back to first the building projects that I worked before.
Okay.
And then I'll talk a little bit about space architecture.
Sure.
So one project, which was really interesting to me, was 380 meter tall tower in China, the Guiyang World Trade Center. When I got into that project, it was still early stage, and it was kind of a concept developed around this idea of a master plan and point tower, signature tower. And then we had this ambition to recreate, and this was it's like inspirational, the idea of like the rice field and rolling hills onto the building facade. But there was also other performative factors to that, confusing wind and flattening the external skeleton to optimize the leaf span, reducing the amount of carbon structure. So there was a lot of other ideas behind that. But the enclosure system was really complex. It was double curve geometry, all meant to be powder coated aluminum. And there were these mega panels that were spanning like 3.2 meters, so like much taller than you and me. and these panels, they had to be built locally. And so the fabricator at that time, they were just testing how to build this thing. And basically what they had to do was create like a formwork, just test it out plywood. Then they would like press stamp the metal, and then they would have to like, basically weld it together and then finish it, sand it. And eventually they came up with this mock. And so the modeling of that, just like the digital representation, was a really interesting exercise because we had to figure out how do we optimize that geometry so it can be repeated in a certain number of families.
I was going to ask you about that.
How do you work with the enclosure system and then the glass units, because the building was tapering, had to change as if you're going up, and you had to like group the building into different segments. And so all that was a part of a 3D model that I developed. And then we gave that to the builder and the fabricator, and then they use that to produce component. And that was just one part of the process. And we also use that model to document the project, and in Revit, and we're like both linking it directly, and there was a change. I would just shoot the information with the engineers, the column site, because for a tower like this, as you go up, the concrete structure gets narrower. So as you go up, it has to like step in. And then the engineer would give us that information. We can plug that into the Excel, the script, which the geometry for the structure. But that was one project. So just thinking, like, how do you design something at scale? How do you work with a manufacturer? What kind of level of detail do you have to develop your model to? How do you document? And then another project I can talk in terms of space architecture, very dissimilar, but I think there's some ideas I can connect between them. So the idea of a large habitat for the Moon Village. This was a project that I spearheaded, where I was very fortunate at that time. I was going to space conferences, again, connecting with people. I had already met a lot of people previously in the space industry years before. And so they invited me to come to a space event, and I'm going to come talk to people and learn about what's going on. And got to meet some key individuals there, including head European Space Agency at that time. And we had a fun discussion about bridging two different worlds. He was actually a civil engineer, in his education. And so he just loved the idea of working with architects to think about large scale developments beyond Earth. And we basically struck up a partnership that evolved over a series of meetings. And eventually we started to work on a concept for a space habitat. And that space habitat is that vertical 4-story habitat that you see if you just search Moon Village, East Lake. And that was when I was working at SOM. It's me and few others at the company were working on this project. It was a really enriching experience because I got to connect with a lot of people outside of my field, people from material scientists and engineers to propulsion experts, radiation experts, just like things that we never talked about in the building industry because we don't need to. And so that really opened my eyes up to what it takes to build infrastructure in space. It's not just about habitation, it's about protecting yourself from the outer space environment, the transportation system that you're constantly be designed for, because that limits the mass and the scale of your habitat. And then the destination, you get it down to the surface of another celestial body, and then how do you transport it? What are the sequence of events getting it from being on the surface to being fully occupied? And these are all actual like problems that we're going to have to solve when we start sending humans back to the moon. And so I got to think about these problems in a certain level of detail, but not too much. And that was really amazing for me to just come up with an idea. It was widely published and accepted and celebrated, and people thought it was a concept, even though it's a little future forward because the habitat is pretty large. Our stories is not, we can deliver anytime soon.
Yeah. Can you talk about that delivery? I mean, it seems like, there's payloads in transport and there's logistics and you've also kind of mentioned 3D printing where you would use available materials, that would be localized to the site, I assume. But all of that is got to be a huge topic of conversation early on in these projects, rather than figuring that stuff out later. There's so many things that are just based on logistics alone. I would imagine that that is part of that conversation so early on.
Yeah, it's like real estate location. So there's also location on the moon that's optimal for resources, for access to daylight, for power, for access to water, ice, and then also for geologic interest. So like the premise of going to space, going to the moon, it's a combination of things like industry, technology development, science from governments, and then also, people just are excited about it. So tourism might play a role in that in the future. And it might be actually a very important role because we need to find a way to subsidize going to space in big ways. But yeah, the resources in outer space are vast. We're always talking about limitations of Earth and how we need to like control our consumption and transforming the planet. But if you stop to think, that just the inner solar system could support, trillions of people if we learn how to harness the resources out of space. And that's one of the most interesting things you can start to think about. So like how can we make useful resources in outer space? Well, maybe we can't bring them back to Earth, but we can definitely go to outer space and harness energy. Can we bring some of that power back to Earth? Or can we develop technologies that we're going out there can be used in terrestrial applications? One of the greatest exports that we'll have from going to space is patents, like new ideas, new technology, patents. And so that will definitely be a measure of progress. Like during the space race, I think that during that period was the lowest number of patents and technology developed, in the history of the U.S.
Right.
So that's where I think it's also interesting. It's a challenge for us to innovate. But resources will play a huge role. And on the moon, for example, if you can harness water, ice, you can turn that into fuel. You can turn that into either and turn that into consumables like water, human. And then if you can learn how to harness the regolith, you can use that for 3D printing. You can use it for producing metals. There's a lot of glass in the surface as well. So all of this would take time, and take a lot of invention because we don't have any machines that can survive the outer space environment, especially on the moon where the regolith is abrasive. And if it gets into any gears, it damages the gears. There's a lot of information about this and during the Apollo missions and how it damaged the suits and the gears and, the materials. So there's going to be a huge, need to innovate there. And resources are just the beginning. The other side is, can we develop a sustainable community?
Right. We
have to rethink how we design spacecraft for habitation. What is the most optimal volume for people to live and thrive for a certain duration, an extended duration? Like the moon missions were only lasting a couple of days, a few days, where in the future, we're going to want to have people go out there for months, maybe years. Like on the ISS, what's the average? 180 days. I think people have spent as long as a year or more up in the ISS. But then if you want to go to the moon, it's quite, it's not that far, but still it's a distance. And if you go there to do any meaningful work, you're going to want to stay there for months.
Right.
To develop technologies and to prove that things work. So that's where space architects come in, and we can come up with ideas. Like, how do we optimize the use of volume? How do we co-locate spaces and function? And then what is the optimal design configuration for a space habitat that has a certain purpose? And so there's a lot of layers we plug into. It's kind of like the role of the architect. We're helping architect a mission, a vision, and then in the integration of all those technologies into that space for human.
Right.
For human.
Right. What inspires you? I mean, not just visually, but technologically. I mean, I would assume that a lot of sci-fi media does a really good job of kind of inspiring people to think beyond traditional forms and the bounds of constraints that we actually have in the physical world now. But it's really interesting to me to see devices emerge, transportation systems emerge that there was conceptual imagery for, way, decades ago that's now happening today. For you, what is inspiring? Is there imagery that exists that's inspiring you that you could point at?
I wouldn't say imagery, but more the hard work of certain individuals out there.
Mm-hmm.
I mean, I'm just going to say it, but SpaceX is doing incredible work. And the idea of going to Mars and building a ship of that scale, super inspiring, because if you can get, that amount of mass to space and to another celestial body, it kind of hits the reset button on what we can design. And so for anybody who's thinking about sending, equipment, technology, or habitation to the moon or to Mars, you can start to come up with different ideas.
Yeah. Very cool.
Even satellites. I mean, even satellite missions, like we used to be able to send small satellites, and the Hubble Space Telescope has brought back a lot of great science and imagery. And then now we're looking at, larger and larger telescopes that can identify other habitable worlds and tell you what the characteristics and can we, how many habitable worlds are out there? That's another cool topic. It's like, can we prove that there's life beyond Earth? And that's one of the premises of Mars. We're searching for signs of life.
Right. It becomes the next jumping off point, right? It becomes the new reset of, okay, now we can look from here instead of looking from where we are right now. Gives us a new perspective. It's really interesting to think about. I'm not sure where I got this idea. I know it's not from my own brain, but the whole idea of the universe is always expanding and the universe is always shrinking, in the way that we're always designing more powerful tools, whether that's a telescope or a microscope, to look at smaller and smaller things. Every time we do that, we just find out that there's more out there. I think that is so interesting. Like, there is no end, magnification wise or telescopically. Like, we just keep finding smaller and smaller things, and we keep finding bigger and bigger bounds to everything. I think that is so interesting. And for us to, in academia, place any kind of boundaries on what is possible for those graduates to go into or achieve is completely ridiculous. To say, these are the firms that exist today, and therefore you need to get ready to work at those firms. Absolutely ridiculous. This is the software that exists today, so this is the software that this is the only thing you'll ever need to learn. I don't know that anybody thinks like that, but I definitely know there have been people who say that and have said that kind of thing in the past. And it's just incredible to me that there are no bounds to any of this. And to find a trajectory of interest for every single individual who's interested in pursuing these fields, it's wide open. There's just so much possibility.
Life is such a short journey. Like, you have to make the most of it, because you're here and then you're not.
Yeah.
It's a brief moment. So just follow what you enjoy. Just make careful decisions along the way. Like, I have a family now, I have 2 kids. And so now my choices are a little bit more calibrated than before. had to think about them too.
Nice.
And it's important to just pursue you want to wake up and do the work that you do.
Yeah. Yeah. Lovely way to end this podcast, I think, right there. That you just summed it up so beautifully. And Daniel, it's been a pleasure having this conversation. I'm hoping we can share some images. People, I think, at this point will have either seen them in the video version of this podcast, or if you listen to the audio version and you want to see some of the imagery of what Daniel was talking about, check out the YouTube version. And I'll put links to everywhere you can find Daniel online in the show notes. And Daniel, is there anything else that you want to tell the audience or let them know a place they can connect with you?
Yeah, feel free to go on my website, connect with me, and if you're interested in a particular topic, just reach out. I always respond. I think that it's important for me to respond to questions. I love working with students and professionals, experts, anybody.
Making connections. All right. Daniel, thank you so much. I appreciate your time today.
Thank you. Take care.